Welcome back to my coding channel, and in a pretty long overdue video, I'm going to resume my tower defense series, and we're going to create circular AI to follow the path that we've created so that we can eventually code enemies into our game. Alright, so to code our AI, we're going to create a soldier class, and this is going to be our basic class that's going to have all that information for each circle that you see on the screen. So I'm going to type class soldier. And the soldier class constructor is going to take these parameters. We're gonna need a starting position for each soldier to spawn at. So that's going to be POS for position. By the way, I'm not doing X and Y. I'm just doing POS because we can already store positions in a single variable using our vector class from our first video. So the position of the soldier is going to be essential. We're also going to need the color, radius, attack power, and starting health for the soldier. Now, most of those are going to be irrelevant for today, like health and attack, because we're not going to add those mechanics yet, but we'll need them for later. So let's add the color for what this soldier is going to be. Maybe different colors can indicate different enemies. We're going to add the radius, so R, which is going to be how big you'll be, health, and attack. And that should be everything we need for the soldier constructor. Now let's go ahead and create our private variables. This dot position, I think I'm also going to use pos. This dot pos equals pos. This dot color equals color. This dot r equals r. This dot health equals health. And then this dot attack equals attack. So we've saved all those variables. Now let's go ahead and while we're at it, let's go ahead and create the draw method for our soldier. This is going to be the function that you call to make the soldier render to the screen. And in fact, I believe I used render. Yeah, I don't say draw, I use render. So I'm going to create a render function which is going to draw him to the screen. Render. And to render the soldier to the screen, the first thing we need to do is run the begin path function with our context up here, context.begin path. Then we're going to set the context color, and in fact we should do that first. Context.fill style equals this dot color. So we draw the circle in the correct color. Now to draw a circle in Canvas, you're going to use the arc function, context.arc. And the arc function takes a lot of arguments. The first two are the position. So that would be this dot position dot x, this dot position dot y. Now we need to know the radius of the arc. So that's going to be r, this dot r. Now we want to know through what angle we're going to rotate, because the arc is not necessarily how you draw circles. It's just how you draw any arc to the screen. So if I wanted a semicircle, I would do 0 to 180 degrees. So I would do 0 and then math.pi. But since we want a full circle, we're going to do 0 math.pi times 2. And that will draw a circle to our screen. Now to finish up with the circle, we're going to call the fill function, context.fill, and that will draw the circle to the screen. But now we're going to need to go back in the constructor, and we're going to need to add a few more things. So as you saw at the very beginning of the video, this circle has a series of, and it's not rendering now, but that I modified the file. But the circle, the AI, as he moved, he was heading towards this position, then this position, then this position, then this position. He had 4 targets, and he moved towards each target one by one. And so we actually need to calculate where each one of these targets are going to be for our soldier to move. And we're going to create a list to hold these targets. So this dot targets is going to be empty list there. And this is how we're going to calculate the target positions. So right here, this target position is simply our start position for our game plus our first path. Let's take a look at that. So here we have the map data. The start position is 100, 0 is this position right here by my mouse. And then the path is the directions you go from your current position. So the first path is down, then the next one is right, and so on. So this very first position is the start position plus the first path. So let's go ahead and calculate that for our soldier. That's actually pretty easy. The very first target, this dot targets 0, is going to be the vector sum of the start and the first path. So that's going to be new vector, and then we're going to use start position dot x plus, and what did I call it? I called it path data. Okay, so path data 0 dot x, start position dot y plus path data 0 dot y. And it's kind of long, but unfortunately we can't just say start position plus path data 0. That's not how JavaScript works. But now we've calculated the very first target in the list. Now we need to calculate all the remaining targets. And the remaining targets are actually easy to calculate. You just need a first one to start with. All the rest of the targets are going to be calculated like this. The next target is simply the second path plus your first target. So target number 1 plus path number 2. This target is going to be your target number 2 plus path number 3. That's how we're going to go from here to here to here to here. Now that might be a lot to wrap your brain around. Feel free to plot. Feel free to pause. Wow, there you go. Best gaffe of my programming teaching history. But let's go ahead and create a for loop that's going to calculate all the remaining targets. For let I be 1, we've already calculated the 0th target. Now we're going to do the first one. I is less than path data dot length minus 1, because again, we already calculated the first target. I plus plus. Now what we do is we need to get the previous path. So the previous path, or the previous target, excuse me, the previous target is simply this dot targets I minus 1. That was the previous target. To get the next target, we just need to add the next path to the previous target. So let the next path is just going to be path data I. Now we add these two together to get our new target. New target is equal to new vector, and we're going to add them together just like we did up here. Previous target dot x plus path dot x, and then previous target dot y plus path dot y. And now that we've calculated the next target, we'll add it to our list. This dot targets I is equal to new target. There we go. And just to make sure we got everything working, for now all I'm going to do is log the new target onto our console. So console dot, in fact, console.log this dot target, or we'll just do new target. New target. Console.log new target. So now let's make sure that everything we have up to this point is working. So we're going to go ahead and create a soldier at the bottom. I'll do it right here. Var soldier equals new soldier, and we need a position. So I'm just going to make this soldier start at the start position. Start position. This soldier will be, I forgot what my arguments were. We need color, radius, health, and attack. So this soldier is going to be red. His radius will be 20 pixels. And his health, 100, his attack, 10. But those don't matter for this tutorial. And now let's go ahead and open up that on our console. And we got a bug, so let's pause and figure out what that is. Alright, we actually have a few bugs to fix. For some reason, when I was setting the next target, I accidentally did new target as two separate words, but we're using the variable here. Also, in our for loop, I was actually shy by one target. We don't need a -1 here. So we calculate the very first target by using our game start position, and then we use a for loop to calculate all the remaining targets. So that's going to be I index 1 all the way to the end of the list. I don't know why I added a -1 here. We were down a target. So now let's go ahead and save that and then refresh. And you have a list of 3 targets here. Now there's 3 targets. There should be 4, but that's because I'm only logging the next 3 targets. I'm not console logging the very first target, but I guess we can do that here. Console.log this.targets 0. There we go. And now let's just see if we get all 4 targets to the screen. And we do. So we get 100, 200, 650, 200, 650, 450, 150, 450. And those are all the correct numbers because all we're doing is, and I'll explain this again in case it wasn't clear, but all we're doing is to calculate each target, you just take the previous target and then add the next path. That will give you each individual target. So we need a starting target to work with, which is just our start position plus our first path. But then after that, we do old target plus new path. And then you can verify these numbers. You can see that it is simply adding these paths to start position one at a time. So now our soldier has a mental list of the vector positions of each target that he needs to travel to. So now we're going to work on drawing the soldier and making him actually travel to each one of these positions. So for that, we're going to need a little bit more code, and we're going to get rid of these console log statements. So now let's go ahead and create a current target variable, this.current target. And the soldier's current target will always be the first one. So that's going to be this.targets 0. So we're going to have a current target, a list of all the targets. We also need a direction. So this.dir for direction. And I'm just going to set it to a vector that's going to be 0, 0 for now. Now we're going to add a speed variable for how fast the soldier will move. This.speed, and I'm going to set it to 4. And we're also going to need a minimum target distance. Don't worry about it too much for now. This.min target distance. And I'm going to set that to something like 2. But here's what that means. That means that our soldier has to be within 2 pixels away from his target before he is allowed to move on to the next target. Now here's why I coded it that way. Your soldier has a speed of 4, so it might be that he's right before the target position, and when you add 4 to his position, he goes past it. So then you add another 4 and he goes in front of it. Then he adds another 4 and he goes back. So I'm not worried about the soldier reaching this exact position, but I want him within 2 pixels from it before he can move on. So now we're going to create the update function, and this is going to be kind of challenging, but we're going to create the function for our soldier which will make him move. It's going to make him follow each individual target. So for that, we need to calculate the direction for the soldier to move. To calculate the direction, what you need to do is you need to take the current target position and subtract the soldier position from that. So here's how that works. In order to get the direction, you take your target position minus the soldier position, and this is going to give you a vector that represents the direction the soldier needs to go to reach that target. So let's calculate that. Let the direction be new vector, and it's going to be our current target, this dot current target dot x minus this dot position dot x, this dot current target dot y minus this dot position dot y. So that's the direction that our soldier needs to go to reach the first target. Now what we need to do to that direction is we need to normalize it. This means we're going to take this vector and we're going to shrink it down to where it is only 1 long, or it has the length of 1. And to do that, we're going to need to calculate its total length. So let the distance, which is basically the length of our direction vector, the distance is going to be, and this part's kind of weird, it's the direction x squared, so dir.x squared, plus the dir.y squared, but you take the sum and you take the square root of it. This is just the Pythagorean theorem. This is how you calculate the distance or the total length of a vector with x and y. So we calculated the vector, then we calculated how long that vector is, and now that we have this, we can go ahead and normalize the vector, or basically shrink it down. So dir.x divided by equals distance. dir.y divided by equals distance. So I know this is some pretty complicated mathematics. I'm going to include a link in this description for, I think, my Slither.io series where I explained all this movement code in a lot more detail, explaining exactly why you need to normalize the vector and do this step. Now, before you watch that video, let me also just explain it briefly with Paint to explain exactly the mathematics that we're using. Here's the soldier, and here in red is the target position the soldier is trying to reach. So the first step we did is we calculated the direction the soldier needs to move. That's going to be the target's position minus our position. And that's what we did with this line of code right here. Target minus our position. And that gave us this direction vector right here that points to our target. Now, this vector by itself is not very useful to us because we can't just add this to the soldier's position. If we did, he would move way too fast and he'd be on the target in 1 instant. What we should be doing is shrinking this down to match his speed. So what we really want is this direction to be only as big as his speed. This is something that we can add to the soldier every frame so that it takes him several frames to reach the target. So here's how you do that step. We got to shrink down the vector by normalizing it. That's what I just mentioned. You calculate how long it is using the Pythagorean theorem, and then you divide the x and y by the distance. That is this step here. Now it is the length of 1. The final thing we need to do is we need to multiply our speed back into our direction in order to make it grow back to here so that we can get our smooth movement across several frames. 1 is too small. We don't want to be moving like this, but our speed will be much better vector. So now that I've explained that, let's continue. We're going to take this direction and we're going to multiply it by our speed, but then add that to our position so we move. So this dot position dot x plus equals direction dot x times our speed. And again, the Slither.io video I made a while ago explains movement, and it's basically what I just said, but I think in a lot more detail. This dot position dot y plus equals dir dot y times this dot speed. There we go. But let's do one more check. Let's make sure that the distance isn't already 0, because otherwise we'd be dividing by 0 right here. So let's just do a quick check. Before we normalize the vector, let's just make sure if distance is equal to 0, then let's just go ahead and return from this function, because we don't need to move if we've already reached our last position. And another thing we should do It's not going to make a difference right now, but we should make sure that if we don't have a current target, we should also exit the function early. So I'm going to add down here, if this dot current target equals null, then we're going to return. So again, as the very first time we run this update function, this won't be a problem. But once our AI has reached its final position, it needs to stop updating. There are no more positions to calculate. And if we tried to keep calculating more, we'd run into some problems. So this code right here moves the AI. Now we need to check if the AI has actually reached his target position. And to do that, we need to calculate the distance between the AI's position and his target. So that's going to be like this. The x distance is going to be this dot position dot x minus this dot current target dot x. And in this case, we're not worried about the sign, so like plus or negative. So we're going to do absolute value, math dot abs, and then I'm going to wrap that in parentheses. Same thing with the y distance. The y distance is math dot abs, this dot position dot y minus this dot current target dot y. And now this is where that variable we created a while ago, the minimum target distance. Honestly, this could be a constant. I just don't know if I'm settled with this value. We'll see. But this minimum target distance is going to come in handy here. We're going to see if this distance is less than that. So if the x distance is less than or equal to this dot minimum target distance, and the y distance between the AI and the target is less than the minimum target distance. If this condition is met, here's what we need to do. This means that this code worked. The direction was calculated, we moved towards that direction, and now the AI is right on top of that position where he needs to be. So now he needs to go ahead and delete the current target from the list that he was tracking, and he needs to set a new target. So here's what we're going to do. We're going to say, well, let's delete that target. So this dot targets dot splice, this is the function you use to delete items from a list. We want to delete the very first item in the list, and we only want to delete one item from the list. So that will delete the current target. Now that we've deleted it, let's reset the current target. This dot current target is now the first item in that list. This dot targets 0. But of course, this is the next target since we just deleted the one that was previously the first one. So this code now will set the next target. And we should also do a little bit of checking first. We need to actually make sure that there is another target left. So after we delete the target, let's see if there's any other targets left. So if this dot targets dot length is 0 and we're out of targets, we need to set the current target to null. This dot current target equals null. Otherwise, we're going to do the rest of the code. Else, and then we'll throw this in that else statement right there. Okay, and with that, we've completed the AI for our moving soldier, and I do need to delete this. This will cause a bug. All right, we have our constructor. We create all the targets in the list for the AI to track. We track those positions here, and then here we set the new position for once we have reached the minimum distance from that position. So now let's go ahead and put this to the test. I'm going to create a list of soldiers, and we're going to see how many soldiers we can add. So let's see, var soldier. So instead of having one solitary soldier variable, we're going to have a list of them. So var soldiers, you know what? Actually, we'll keep it as one soldier just to make sure that it's all working. Then we'll make it a list. So in our update function, we're going to update this soldier. Soldier.update just to make sure he is working. And then we need to also draw the soldier. So that's going to go inside of our render function. We'll do it after we draw the path and the grid, which you can recall from the last video. Soldier dot render. Now, it's likely that there'll be a mistake. Let's go ahead and test our code. Whoa! All right, so something very funny just I've never actually seen this bug. It moved the entire road. Let me go ahead. I want to see that again. That's really funny. So I've built this particular stage several times. I've never seen it do that. So let's pause and figure out what it was. While coding for this tutorial, I forgot a fundamental aspect of JavaScript. When I created the soldier, I passed in as a parameter the starting position for the soldier's starting position, but I forgot something about JavaScript. When you pass a object into a function as a parameter, and in this case the function is a soldier constructor, it does not create a copy of that value. It actually passes in the real value. This is called passing by reference versus passing by value. So start position, when I used it to be the soldier's starting position here, we did not get a copy of start position. This position is not just equal to start position. This position is the same object as start position, which means when we tried to move the soldier right, where did we do it? Here. This dot position is actually just a reference to this variable down here. So we're actually modifying the game's start position whenever we move the soldier. So what we need to do, and again, that's called passing by reference. We passed an actual reference of start position to the soldier. We just need to pass a copy of its value. So here's how we're going to do that. We're going to create a vector object that has the exact same value as start position. StartPos.x, startPos.y. So this has the same numeric value as start position, but this is its own object. It is not the same variable object as start position. So you just create a new vector, but it has the exact same x and y as the start. Now I'm going to refresh that and run, and the AI does actually follow the path. Now you're going to notice when he reaches the path, he actually goes off of it a little bit. And that's because there is a few bugs. There's actually like one bug with the render path function, but I'm going to go ahead and address that in the next video. Well, actually, before I congratulate anybody, let's go ahead and create the soldier list now. Let's have several soldiers. So instead of just one soldier, that's all good, but let's do soldiers. Var soldiers empty list equals that const num soldiers, and let's have 10 soldiers follow this path. All right. And now here's what we'll do. We're going to create a for loop. For let I be 0. I is less than num soldiers I plus plus. And we're just going to go ahead and create all 10 of those soldiers. Now, what I'm going to do, though, for each soldier, I don't want them to all move at the exact same rate, but I want them to each have a starting position that's a little bit further back than the last one. So I'm going to have a soldier start position variable, var soldier start, which is going to be the same value as our game start position. Like that. And now every single time we spawn a soldier at the start position, we're going to decrease, or actually we're going to make this start position a little bit higher. So let's go ahead and create the soldier. Let soldier be new soldier, and he will despawn at soldier start. His color will be, let's just make sure the colors work. I'm going to do blue this time. The radius will be 20 pixels, health 100, attack 10, even though we're not using those. We're going to add the soldier to the list. Soldiers.length, which is the next available slot, equals soldier, like that. In fact, I'm just going to call this new soldier so we're not confused. Rename this new soldier. All right. But every single time we create a new soldier, we're going to decrease the, we're going to decrease the Y value of the start position. So soldier start dot Y minus equals 30. There we go. So this should spawn 10 soldiers, all of which will be at different positions. Now that we have our soldiers list, let's go ahead and update all the soldiers instead. So soldiers dot for each function S for soldier, add my curly brackets, parentheses, semicolon, S dot update. And I'm going to copy this and I'm going to slap this on our render function. Instead of soldier.render, it's going to be s.render. All right, let's make sure we did all that correctly. And by we, I mean me. Refresh. That was amusing. Okay, let's go ahead and figure out what this one is. I once again made the same mistake. I passed a vector variable to the soldier constructor, but again, that passes by reference, meaning an actual reference to this variable is sent to the constructor. So when the soldiers try to move their positions, they're actually just moving this starting point. So what I need to do is make sure I'm passing just a copy of the position variable. So I'm going to create a new vector that has the exact same value. Soldier start.x, soldier start.y. And now I save that, refresh, and we're going to get a much better result. Now you can see them all following each other single file, and of course they're all going to converge on this position. Just for fun, let's go ahead and add some more soldiers. Let's make it 100. Let's see what that looks like. All right, and that's perfect. I'm going to end the video here. You have now successfully added AI to your tower defense game. Thank you for watching.